Hello everyone, this is the model answer for the foundation, resistance, voltage and current exam questions. A student used electrical circuits to investigate the relationship between resistance, potential difference and current. Figure 1 shows how the student connects the first circuit he set up. Circuit does not work. You've got to try and draw the correct circuit. So there's two reasons why this doesn't work. The first one I've circled here. He's got two cells to make a battery, however, one of them is connected the wrong way round. When we connect cells together, we must make sure that the positive is facing a negative terminal, not two positives or two negatives facing each other. So that's one of the reasons this circuit doesn't work. The other one is to do with the voltmeter and the ammeter. These are actually the wrong way round. Ammeter must be connected in series with the thing that you want to measure the current through, and the voltmeter must be connected in parallel or across the component that you want to measure the potential difference of. So I'm going to draw the circuit out again, but I'm going to do it correctly. So I'm going to start with the cells. We need to have positive to negative on the terminals. And then the rest of the circuit makeup is pretty much okay, apart from the ammeter and the voltmeter that need switching around. So when I'm drawing this again, I'm going to put my ammeter here. Using a rule is always a good idea for circuit diagrams. It just makes them look a lot neater, not as messy, more organised. And then I'm going to put my switch in. So this is showing we've got an open switch at the moment. When he closes it, this new circuit should work. And then I'm going to put the voltmeter across the bulb because that's what I want to measure the potential difference of. Okay, so we're going to end up with a nice, neat circuit diagram. And it's worth 2 marks, so it's 1 mark for each of the mistakes that you have spotted. On the next question, next part of the question, the student set it up correctly using the diagram that you've just drawn. And he has got here a figure showing the reading on the voltmeter. It's asking what the reading is. So we need to work out what each of these little divisions is. So between 0 and 1, we've got 1, 2, 3, 4, 5 divisions. So each one is worth 0.2. So I can see that my reading is 6, but then I've gone over by 2 little divisions. So that's going to be 0.2, 0.4. So it's going to be 6.4 volts. The student then set up a circuit to investigate how resistance affects the brightness of a lamp. Figure 3 shows the circuit that he set up. So we've got a cell, a lamp, and we've got here a variable resistor. The student increases the resistance of the variable resistor. What effect does this have on the brightness of the lamp? Explain your answer. Okay, so the first thing that we need to realise is if we increase resistance, we'll decrease the current. Okay, and the current is to do with the rate of the flow of charge. And this is what's taking the energy to the bulb. So if we actually increase resistance, we're decreasing that. So the thing that's going to happen is the lamp will get dimmer. That's only 1 mark. You need to then explain that. So the explanation would be increasing resistance decreases the current. So using your knowledge of the variable resistors and how resistance affects current flow. So the next bit is an equation recall. So write down the equation that links current, potential difference and resistance. So a little bit of a hint for these questions. They always give you the values in alphabetical order. And if I were you, I would write the words out. because if you forget the symbol for one and you make up your own symbol, then the whole thing will be wrong. So the answer to this one is potential difference equals current times resistance. For those of you that are really good at remembering symbols, it's V equals I times R. But again, so say if you can't remember that I is current and you put a C in there, then you will get that wrong because C is a different value. When the potential difference across the lamp is 3.3 volts, the current is 0.15 amps. Calculate the resistance of the lamp in the student's experiment. So we're going to use the equation above, and this is why learning the equations is important, because if you don't have that equation, then you won't be able to use it here. So potential difference is 3.3. The current is 0.15, and we want resistance. So we need to actually rearrange this equation. So R is going to be 3.3 divided by 0.15, and the answer is 22 ohms. So well done guys for completing this question. I hope you did all right. If you have got any massive problems, please email me and I will get back to you about it. Thank you.